Hello, my dear students. I was speaking about the drift velocity. Now what I want to speak about is relaxation time before this derivation. What do you mean by relaxation time? Relaxation means free, correct? Okay, in the same way, relaxation time means the time interval between two successive collision. The time interval between two successive collision means, see, I said there are large number of free electrons in the metals. That means when one electron moves, the other electrons will also be moving. So there is a possibility of one electron collision with the another electron. Just like the fest. In a fest, car fest or any other fest, there will be a crowded. People will be crowded, correct? When we move, we should be so careful that our ornaments, anything will be stolen by someone. Or when we move, someone will collide us. That is, they'll push us and they'll move. Correct? So in the same way, when there are large number of free electrons, one electron may collide with another electron. So the time interval between the two successive collision, one electron starts moving from here. Before it collides with another electron, what is the time period is present? That time interval is nothing but relaxation time. So relaxation time is nothing but the time interval between two successive collision. It is nothing but time interval between two successive collision. Okay, time interval between two successive collision. Next, what I want to speak about, SION, collision. And it is given by tau. Time interval is given by tau. Next, now we will derive the expression for drift velocity. Derive the expression for drift velocity. How to derive? But this question was asked in the year 2016. Okay. Derive the expression for drift velocity. How to derive this expression? Can you help me for this derivation? They may ask you to write the definition of drift velocity and then you have to write. Okay. So before deriving it, write the definition of the drift velocity and then you have to continue with the derivation. Consider the free electrons in a conductor. The average velocity of the electrons will be 0 since they are moving in random direction. So let us consider a conductor. Let us consider, you write on your own, okay? Let us consider a conductor with a large number of free electrons in it. Okay? These free electrons are randomly moving in directions. So therefore, average velocity is 0. When an external electric field E is applied, the electrons are drifted with the velocity Vd. Correct? When an external electric field is applied, the electrons are drifted. The force on the electric field present is F is equal to E. Why? When the external electric field E is applied, better we'll speak like this. What we'll do? Let us consider a conductor having large number of free electrons in it. These free electrons are moving randomly since there is no external electric field. Okay. When an external electric field E is present, the electrons will be drifted in one particular direction with the velocity Vd. Okay. The force on the electron is F is equal to minus E into E. Why minus E into E? where minus E is nothing but charge, because you know F is equal to QE. Q is nothing but now minus E. Electrons are moving. Therefore, minus E. F is equal to minus E into E. Okay. We also know that force is nothing but mass into acceleration. ma. So, therefore, I can write ma is equal to E. Correct? Or if you want to write a vector form, we can write it like this. Am I right? Am I right? Then acceleration A is equal to minus E by m. I can write A is equal to minus E by m. Correct? Next. Initially, when there is a random motion, the electrons will move, collide and then move. Correct? So, when the electric field is applied, they will be drifted with some velocity. So, what I will do is, let us consider an ith electron. Okay, we will consider an ith electron. So, Vi be the velocity of the ith electron at any instant of the time t. N number of electrons are there. Let it be the velocity of ith electron in the time t. Well, Vi be the velocity of the ith electron in the time at any time t. If Vi, small letter Vi, is the velocity of the electron, just after collision. So, we will call it as initial velocity, correct? Let Vi be the velocity of the electron just after collision. Then, we can write, and also we know that, see here, V is equal to V naught plus AT. Correct? We know that V is equal to V naught plus AT. Then, we can write V is nothing but final velocity of the ith electron, correct? Is equal to initial velocity plus acceleration. Where is this? Minus E by m. Time interval. What is the time? T. Correct? In the time T. So, since now for ith electron we will give it as Ti. Is it fine if I give it as Ti? Yes, let us give it as Ti. Now, what is the velocity of the electron just after the collision? When it collides, it stops. So, velocity just after the collision is actually 0. See, since Vi is equal to 0, Vi is equal to minus E by m into Ti. But what is this Ti? This Ti is nothing but tau. Why it is tau? Collision, that is nothing but relaxation time. This is nothing but actually relaxation time. The time interval before collision. So much time it takes place before collision. So, Vi is equal to, because velocity of that we will calculate within that time period. Which time period? Before it collides. Now, it is nothing but our relaxation time. Vi is equal to minus E by m into tau. Now, this is for ith electron we have written. In general, we can write it as Vd, correct? Vd, drift velocity. It is nothing but a drift velocity. The electrons will be drifted with the velocity minus EM by, E by m into tau. This is the expression for drift velocity. See here, I can also write, when we write here, better to write the vector form. Okay? I'm sorry. Because otherwise you will forget that it is a vector. Correct? So, E tau by m. The electron moves with an average velocity is independent of time. It depends upon the relaxation time. Correct? What we have done? Let us consider a conductor having large number of free electrons in it. Now it is moving randomly in all directions. Therefore, average velocity is 0. When an external electric field E is applied, the force exerted on the electron is F is equal to E into E. But since it is electron minus E. This formula has come from the which formula? F is equal to QE. Okay. We know that F is equal to MA. So, by equating these two equations, equation 1 and equation 2, so from 1 and 2, MA vector is equal to EE vector. So, A vector is equal to minus EE by M. Let V by I be the velocity of ith electron and time interval taken place is Ti. Time taken for this velocity to calculate is Ti. So, let Vi be the velocity of that electron just after the collision. Okay, we know that V is equal to V naught plus AT. So, Vi is a substitute for that, that is Vi is equal to Vi just after collision, this is a final velocity, plus EE by m into Ti. Since just after the collision, velocity is equal to 0, Vi is equal to 0. Vi vector is equal to minus EE by m into Ti. This time interval is nothing but called as relaxation time. Correct? So, during those times there is no collision. So, this is nothing but time interval between two successive collision. And that is nothing but our drift velocity. So, Vd is equal to EE by m into tau. This is the expression for the drift velocity. Understood? Please write this derivation. This is important for 3 marks. Very, very important for 3 marks. Okay? Next, what we are going to do is, we have learnt the expression for mobility also. What do you mean by mobility? It is the magnitude of the drift velocity by electric field, correct? Okay, now tell me, what is the expression for the mobility then? What is the expression for mobility then? Mu is equal to magnitude of the drift velocity by electric field you have written. Can you write? E by m into tau, correct? Divided by E. Now give me the answer. Can I write it as minus, instead of minus now it is plus E tau by m is equal to mu. Can I write it like this? E tau by m, this is nothing but the expression for mobility of the electron. Why it is E gets cancelled, so the remaining is E tau by m. This is the expression for mobility. Then what is the unit of mobility? What is the unit of mobility? Charge. coulomb second. What is m? Mass. So kg. Correct? Coulomb second per kg. Is this one? Is this one? See, the SI unit of mobility is meter square per volt per second. Why we write that is, it is nothing but Vd by E. What is the unit of electric field? Can you help me? What is the unit of electric field? Using that one we are writing here. Unit of electric field is how much? What is the unit of electric field? Newton per coulomb. Correct? Velocity by E. So, meter per second. And here, what is the unit of electric field? Newton per coulomb. So, what I can write? Newton per coulomb will become coulomb, Newton coulomb meter per second. Is it correct? Is it correct? So, instead of writing so much, in terms of voltage we will write. Therefore, directly I will write the unit of the SI unit of the mobility is meter square per volt per second. And it is your work, one small homework, how we got this SI unit. You have to write it and show me for this one. I will not write it now. You have to write it and show me. Homework. You will write it now. And mobility is always positive because it is magnitude. Correct? Then, you have to write the definition of resistivity also. Okay? How will you write define resistivity if the question is asked? What do you mean by, define resistivity? Resistivity is nothing but, what is resistivity? It is defined as the resistance of the material of unit length and unit area of cross section. See here, R is equal to rho L by A, correct? So, resistivity rho is equal to RA by L. We wrote it that time itself. Resistivity is equal to resistance of the material having unit area and unit length. Correct? When area is equal to 1 and length is equal to 1, resistivity is equal to resistance. So, resistivity is defined as the resistance of the material of unit length and unit area of cross section. Resistivity is equal to resistance of the material having unit length and unit area of cross section. You can write the definition now. No confusion, right? And conductivity is nothing but reciprocal of resistivity. Okay, next.